Hello everyone, welcome to the third lecture of implementing linked list. In this lecture, I'll be walking you through of how you can figure out the size of the linked list. So basically there will be two ways. One is iterative and one will be recursive. So let's jump into the code. So here in the coding section, first I want to make few changes to the already written code, which is I just want to change the name of the function. So because this is a display function written in iterative, I'll make it iterative. And this function is recursive. So we'll call it recursive. And yes, here to change. Let's also swap. So it displays. Okay. And here let's call it iterative. So now we have to figure out the size of the linked list. First, we'll be discussing the iterative approach for it. So this function, I'll name it as size iterative. So this function will be returning an integer, which is nothing but the size of the linked list. It will take a temporary node as input as a function parameter. And let's declare a variable of size 0. So all we have to do is to traverse the linked list, just like how we have already done for printing the linked list here. So the code remains almost the same. We have to jump from one node to the next one. So that part remains the same. Temp is equal to temp of next. And only thing is we have to increment the size pointer. And finally, we have to return the size pointer. So that is all. To figure out the size of the linked list, all we had to do was we had to create a variable and initialize it with 0. And when we are jumping from one point to another, we just have to increment the pointer so that we are aware of how many nodes we have jumped. And we have to return when the while loop finally breaks. So let's try to compile this. Okay, let's run this. 1, 2, 3, 4, 5, 6, 7, and Vic. Oh, I forgot to call this function from the main. So size is equal to, let's call it, let's pass the head and size of linked list is sz. Yeah, so I've called this function from the main now. Let's try to recompile it. So yeah, the linked list is also printed. And after that, the size of the linked list is 7. So why is this printed? Because in the main function, I had also invoked the display function. So it is printing that. Now we have seen how we can print the size of the linked list in iterative fashion. Let's try to do this in recursive now. So to print it in recursive, let's do it. Let's create another function, which is size recursive. And let's get the head pointer in temp variable here. So for writing recursive code, the first thing is the base case. And the base case basically means the smallest valid input. So what is the smallest valid input for the linked list? So we don't have a linked list. That is the smallest valid input. So if temp is equal to null, then all we have to do is return 0 because we do not have a linked list. So the size of the linked list is 0. And in the next case, we just have to call this function with temp of next. And we have to increment the value by 1. So we will call this size recursive function with temp of next. And because we have already processed this node, for that we have added 1. And we will return that. And this should work fine. So let's try to execute this recursive function now once. Here I'll change the function to recursive. And let's compile, rerun. So we are getting the size of linked list as 3, and we had invoked the recursive function. So it is working fine. Now there is one small optimization which you can do to this recursive function, which is that at the moment this function is about 4 lines, right? So we can break it into one single line, which is, so I will not be removing this code. I'll rewrite it. And here I'll remove the if block. And all we have to do is we can use the ternary operator. If you're aware of the ternary operator in C++, then how it works is, so here what I've done is I have used the ternary operator, which is nothing but the question mark and colon operator. You can read about it, how it works, if you're unaware. So if the temp is valid, then whatever is after the question mark is executed. So if the node is a valid, then we are calling the function to do recursion with the temp of next, and we are computing the current node with this +1 value. If the temp is null, that means we are at the end of the linked list, or either we don't have a linked list, then we return 0. So this function should work fine. Since we have already called this function from the main, we don't have to call it again. Let's try to compile and let's execute it. So we are getting the correct answer that the size of linked list is 9. So these were the 3 approaches which I wanted to show you of how you can print the size of the linked list, which was iterative one, and then recursive one, and then simple recursive one. So one mistake that people can do here is they might think, okay, because it is a small function, maybe we can write it as inline. But that is not a good approach here, because inline functions should not be recursive. Since this function is recursive, we should not write inline. And even if we write, it will not make any difference. The compiler will not be making this function inline, because it will know that we are doing recursion here. So it will not convert this into inline. Inline does not force the compiler, but it just suggests them that maybe you can just copy paste the contents of the function to where it was invoked. And this gets rid of the overhead call that we have. But in recursive function, the compiler will just ignore it. So the code I will be attaching somewhere in the description. Make sure to check it out, try to tweak with it, try to play around with it, and try to change some things and try to analyze the behavior, how it is working. So that is it for the video. In the next upcoming video, I will be discussing the memory layout in C++, and I will also be discussing how we can free the resources that we have allocated in heap. So if you like the content, make sure to like, share, and subscribe, and I will see you in the next one.